Any substance could be used to build a barometer, but the most practical application uses liquids. And within liquids, the greater the density of the liquid, the smaller the height of the column to measure typical pressures will be required. So we have over here, pressure is density times g, the acceleration due to gravity, times the height of the column. And if you go ahead and work the units out there, you'll find out that it comes out to be force per unit area. So our statement is the greater the density of the liquid in the barometer, the lower the height that is needed to balance the atmospheric pressure. And up here we have an example. If we're measuring 760 millimeters of mercury, roughly atmospheric pressure at sea level, that's a column of mercury 2.5 feet. You can do the unit conversion from millimeters to feet, and it works out. If we used water instead of mercury, look at the density difference. Mercury's density is 13.5 times that of water. So the height of the column of water would be roughly 13.5 times the mercury. So to measure atmospheric pressure with a very simple device like this, you'd need a 2.5 foot long tube for the mercury and a 34 foot long tube for the water. Not terribly practical. As weather systems move through an area, the mercury levels in your barometer rise and fall as the local atmospheric pressure changes. Rises when the pressure gets higher, falls when it gets lower. The standard atmospheric pressure of 1 atmosphere, or 101 kilopascals, will support a column of mercury 760 millimeters tall. So another unit of pressure, and we've actually talked about this on a previous slide, is millimeters of mercury, also called a torr. So 1 atmosphere equals 760 millimeters of mercury, 760 torr. Probably named after the Italian physicist Torricelli. Not a lot going on in this slide, however. Click here and it'll give you a very nice video on how barometers, which is what this is, works. Barometers are also used in aviation, and they're part of something called an aircraft altimeter. That measures the altitude of the aircraft, which is very important for the pilot to know where he is, kind of in the Y direction, the up direction. As the air pressure will be decreased at altitudes above sea level, there's less air pressing down on your head, the actual reading of the instrument will be dependent upon its location. This pressure is then converted to an equivalent sea level pressure so you can report and adjust your altitude. Now, aircraft fly between regions of different normalized atmospheric pressure, right? Because the atmospheric pressure is not just due to how high you are above the ground. It also depends on weather systems. So pilots continually get updates on the barometer as they fly so they can correct their height depending on what weather system they're in. The storm pressure of Superstorm Sandy was recorded as 0.940 bars. As an exercise, convert that to atmospheres, millimeters of mercury, and torr. Notice that's less than normal atmospheric pressure, and that's typically what happens with storage. You have a low pressure event. So take a couple, minutes, seconds, whatever you need to work on it, pause the video, and when you're ready, come back and I'll move the answer bar here. Okay, let's move it and see what we get. So this is basically just unit cancellation. We start with 0.940 bar. We know that 1 atmosphere is 1.01 bar, so we get 0.931 atmospheres. We can also convert it, knowing that 760 millimeters of mercury is 1.01 bar, and we get 707 millimeters of mercury. That means if you had a barometer like that, you would see the mercury level falling. And then converting into torr, that's a simple one. 1 torr equals 1 millimeter of mercury. So we take this mercury over here and convert it, and we get 707 torr. So there's a lot of different conversions here, all giving us equivalent answers.